Introduction. This video is a part of series Digital Image Processing in Qt that will introduce how to implement some digital image processing mechanism in Qt. This tutorial is suitable for persons who's starting to study QML language or implement digital image algorithms. In this video, we will introduce some information of the DADIP library such as file structure, basic data type, file I/O, image I/O, file structure, basic data type header. This file defines some general information that are used by all of apps. Basic data types. The common data types of C language are used by the DADIP library. Mathematic operation. Mathematic operations are also declared here. Error codes. They help user understand about situation of library. Macros for memory and error processing. Used to allocation and free memory. In case of error op, you will go to error processing segment. File I/O header. This file defines some data structures and method for reading from file or writing to file. File reader structure. It includes objects and method to manage the reading of file. File writer structure. It includes objects and method to manage the writing to file. DADIP create file reader. Method to create the instance of file reader. DADIP create file writer. Method to create the instance of file writer. File I/O source. This file implements for method that reading from file or writing to file. Implementation of read amount of data from file. Based on user input, the function allocates the memory and read data to here. Implementation of destroy file reader instance. Release object and file reader instance. Implementation of seek to the new position. Set the file position of the stream to the given bytes. Implementation of DADIP create file reader. Allocate DADIP file reader structure. Open file. Assign elements of DADIP file reader. Implementation of right amount of data to file. Write from user input buffer to file. Implementation of destroy file writer instance. Release object and file writer instance. Implementation of DADIP create file writer. Allocate DADIP file writer structure. Open file. Assign elements of DADIP file writer. Image.io header. This file defines some data structures and method for some basic operations to image. Basic image structure. It contains base image with some global elements. Image type, BMP or grayscale. Width height, image resolution. Depth, bytes per pixel. File reader writer, file handling. Parse image, image fully parsing after header parsing. Destroy, release image. Pixel array, store image data in one-dimension array. Extract insert data from to buffer. These API are useful when we read-write the image files. DADIP allocate pixel array API to create the blank pixel array. Output is the array with default value is 0 for each pixel. DADIP free pixel array API to free the pixel array. Release memory area where stores pixel array. DADIP create image empty API to create the blank base image. DADIP create image copy API to create the image with base image data is copied from input image. DADIP check image type API to find the type of image by reading the file header. DADIP get bytes from depth API to calculate the number of bytes per pixel. Macro for pixel array manipulation. Access data at specific location in pixel array. Image.io source. Implementation of API to extract insert data from to buffer. Implementation of DADIP allocate pixel array. This will allocate memory area based on user input and clear all pixels by 0. Implementation of DADIP free pixel array. Release memory area where stores pixel array. Implementation of default destroy method of base image. Release memory area where stores base image. Implementation of DADIP create image empty. Allocate image structure, create the blank pixel array. Implementation of DADIP create image copy. Allocate image structure, assign global elements of image, allocate pixel array, copy input image to output image. Implementation of DADIP check image type. Find the type of image by checking its header. Implementation of DIP get bytes from depth. The number of bytes per pixel is decided based on depth.